So, let's talk about a force that powers our entire world, but is completely invisible. We're going to go on a journey from ancient mysteries all the way to the foundation of modern life to really understand how we unlocked one of the most fundamental forces of nature, electricity.
You've probably heard this quote before. It's supposedly from the great scientist Michael Faraday. And honestly, whether he actually said it or not doesn't really matter, because it just perfectly captures the spirit of this story. When some politician asked him, what's the practical use of all this, his reply hinted at the immense, world-changing potential that was hiding in plain sight.
For most of human history, electricity wasn't something you plugged into a wall. It was a strange and sometimes literally shocking mystery. Our journey starts way back in the ancient world, where the first encounters with this force were just weird, fleeting, and nobody had a clue what was going on. What's just incredible is how long we've known about electricity without knowing what it was. I mean, we're talking nearly 5,000 years ago. Ancient Egyptian texts mention electric catfish. Fast forward a couple thousand years, Roman doctors were using jolts from electric rays to treat headaches. Then, around 600 BCE, the Greek philosopher Thales of Miletus noticed that if you rub some amber with fur, it suddenly attracts feathers. That's the first time anyone wrote down anything about static electricity. But even he got it wrong. He thought it was some kind of magnetism. And that's really the key here. For thousands of years, from zappy fish to staticky amber, electricity was just a curiosity, a kind of party trick, maybe a philosophical puzzle. Nobody was talking about charge or current or fields. It was just this weird property that a few things in nature had. So, how did that all change? Well, the scientific revolution was the big turning point. Curiosity started turning into actual concepts as a whole series of brilliant minds began to really investigate, measure, and finally define this mysterious force. The first giant leap forward was figuring out its source, electric charge. It's a fundamental property of matter, just like mass is. This charge is carried by tiny subatomic particles, the proton, which we call positive, and the electron, which is negative. And believe me, this one idea is the bedrock for everything else we're going to talk about. And this right here, you probably remember this from science class, is the key that unlocks everything. A guy named Charles Augustin de Coulomb figured out this beautifully simple rule in the late 18th century. He realized charge comes in two flavors. Put two of the same kind together, and they push each other apart. But put two opposites together, and they pull right toward each other. Simple, elegant, and absolutely revolutionary. Once that basic rule was down, the pace of discovery just exploded. It was like a domino effect. In 1752, you've got Benjamin Franklin with his famous kite experiment, proving lightning was just a giant version of the static from the amber. Then, in 1800, Alessandro Volta invents the first battery, and that was a total game changer, because for the first time, scientists had a steady, reliable source of electricity to experiment with. Now this is one of those fantastic aha moments in science history. Hans Christian Ørsted is getting ready for a lecture, and he happens to notice that a compass needle on his desk twitches every time he turns on an electric current in a wire nearby. It was a complete accident, just a little twitch, but it was the first real proof of a deep connection between electricity and magnetism, two forces everyone just assumed were totally separate. And just like that, Ørsted's little discovery gave birth to a whole new field. Electromagnetism. What he stumbled upon was that a moving electric charge, what we call a current, doesn't just flow. It actually creates a magnetic field around it. This wasn't just interesting, it was the key that would finally unlock the world-changing power of electricity. This discovery revealed this just perfect symmetry. And Michael Faraday, what a genius. He jumped all over it. First, he figured out that if you run a current through a wire inside a magnetic field, the wire moves. Boom, that's the principle of the electric motor. But then he flipped the whole idea on its head. He thought, well, what if I move the wire through the magnetic field? And he found it created an electric current. That's the electric generator. Electricity could make motion, and motion could make electricity. The modern world was basically born in that single realization. Okay, so the scientists had figured out the what. Now the torch was passed to the engineers to figure out the how. The challenge wasn't just to understand the force anymore, it was to tame it, to scale it up, and to use it to power a whole new age. And to get a sense of what they were up against, think about this. A big lightning cloud can have an electrical potential of over 100 million volts. That's the raw, wild power that nature throws around. The engineers of the late 19th century were trying to take that exact same force and make it safe and reliable enough to light up a single light bulb in your house.
And this new challenge brought out some of the biggest names in the game. You had Thomas Edison, a brilliant inventor, and an even better marketer, who was all in on direct current, or DC. His vision was basically a power station on every city block. But then you had Nikola Tesla, who had this totally different idea, alternating current, or AC, which he realized could be sent over huge distances. And with the money from George Westinghouse, Tesla's AC system ended up winning the famous War of the Current.
So, why did AC win? It all comes down to one absolutely ingenious device, the transformer. See, a transformer can easily step voltage up or down. This meant you could generate power, crank the voltage way, way up to send it hundreds of miles with almost no power loss, and then step it right back down to a safe level to be used in homes and factories. That simple device is what made our modern power grid possible.
And the results of all this? Well, it was nothing short of a complete transformation of society. Electricity went from being a lab experiment to the actual lifeblood of the second industrial revolution. It lit up the night, it powered factories, and it totally reshaped what daily life looked like for millions of people.
But the story doesn't stop with big motors and bright lights. Nope. The next chapter takes us from the massive to the microscopic, from just harnessing raw power to delicately controlling the flow of individual electrons to process information. Welcome to the electronic age. This leap was just as mind-blowing as the first one. It started with these really crude devices, like something called a cat's whisker detector in early radios. But the real revolution came in 1947 at Bell Labs with the invention of the transistor. This tiny little thing could do everything a big, fragile, power-guzzling vacuum tube could do. It opened the door for the incredible miniaturization we see today, where we can cram billions of them onto a single tiny chip. And this is a really key difference, It's what separates electronics from electric power. Power engineering is about making and moving huge amounts of energy. But electronics? That's the delicate art of controlling the flow of electrons to manage information. It's the science behind every single computer, smartphone, and network on Earth. Look, it's almost impossible to overstate how important the transistor is. It is, without a doubt, one of the most important inventions in human history. Every single digital device you own is basically just a complex arrangement of millions or billions of these tiny little electrical switches. It is the fundamental atom of the information age. Which brings us right back to today. From the twitch of a compass needle in a lab to the supercomputer in your pocket, we have woven this invisible force so deeply into our lives that we don't even see it anymore. It's just there, the silent, constant foundation for everything we do. So the question I'll leave you with is this: what does a day without it actually look like? Seriously, think about it.